This video teaches the exact protocol for using Musa peels as a supplemental soil amendment for summer fruiting crops. You will learn the chemical composition of these organic materials, the three most effective delivery methods for nutrient uptake, and the biological process required to convert waste into bioavailable minerals. By the end of this breakdown, you will be able to supplement your tomato, pepper, and cucurbit plants with targeted potassium and phosphorus without relying solely on synthetic inputs. In the United States, organic matter constitutes approximately 30% of municipal solid waste, with fruit and vegetable scraps representing a significant portion of lost nutrient potential. For the home gardener, ignoring this resource is a missed opportunity for soil optimization. Summer fruiting crops, particularly tomatoes and peppers, are heavy feeders that require high levels of potassium to regulate water movement and fruit development. University research indicates that a lack of available potassium during the flowering stage leads to reduced fruit size, poor flavor profiles, and increased susceptibility to environmental stress. Furthermore, the cost of high-quality organic fertilizers continues to rise, making the efficient recycling of domestic organic waste a practical economic strategy for maintaining a productive garden. Utilizing these materials correctly ensures that nutrients remain in a closed loop within your local ecosystem rather than being lost to a landfill.
Point 1. The mineral profile and plant physiology. Understanding the chemical makeup of a banana peel is essential before applying it to the soil. On a dry weight basis, banana peels contain approximately 42% potassium, which is significantly higher than most other organic waste materials. They also provide approximately 3% phosphorus, alongside essential micronutrients including magnesium, calcium, and manganese. Potassium acts as a catalyst within the plant, managing the opening and closing of stomata, which are the pores on the leaves that regulate gas exchange and water vapor release. This regulation is what allows a tomato or pepper plant to survive high heat afternoons in July and August. When potassium levels are optimal, the plant can maintain internal pressure, or turgidity, preventing the wilting that often leads to stunted growth. Phosphorus, while present in smaller amounts, is the primary driver of ATP, adenosine triphosphate. This molecule provides the energy required for the plant to convert sunlight into the sugars that fill the fruit. Many gardeners believe that placing a whole banana peel on the surface of the soil provides immediate food for the plant. This is incorrect. Plants cannot eat organic matter. They can only absorb inorganic ions dissolved in water. A whole peel sitting on the surface is unavailable to the roots and will likely dehydrate, locking the nutrients inside a leathery casing until it eventually breaks down over several months. To utilize the minerals effectively, the peel must be processed to increase surface area. Dehydrating peels and grinding them into a fine powder allows for faster interaction with soil moisture and microbes. For a standard 12-inch diameter pot or 1 to 2 square feet of garden bed, the application of 2 tablespoons of dried, ground peel powder provides a targeted boost of slow-release potassium during the peak flowering stage. Think of a whole banana peel as a locked safe containing cash. The nutrients are the money, but the plant does not have the combination. You must use processing methods, like chopping or drying, to act as the locksmith, making the cash accessible for the plant to spend on growing fruit.
Once you understand the chemical value of the material, you must choose the correct delivery system to ensure those nutrients reach the root zone. Point 2. nutrient bioavailability, and application methods. There are three primary scientific methods for transferring nutrients from the peel to the plant. Liquid extraction, often called banana peel tea, involves soaking peels in water for 48 to 72 hours. Through the process of osmosis, water-soluble potassium and small amounts of phosphorus leach into the liquid. This provides the most rapid delivery system, as the nutrients are already in an ionic form that the roots can absorb immediately upon watering. The second method, dehydration, involves drying the peels at 150 degrees Fahrenheit and 65 degrees Celsius until brittle and then grinding them. This creates a shelf-stable soil amendment that functions as a slow-release fertilizer. As soil bacteria break down the small particles, the nutrients are released over a period of 2 to 4 weeks. The third method, trenching, involves burying chopped peels 4 to 6 inches below the soil surface. This method relies entirely on the local microbial population to decompose the organic structure. While it takes the longest, typically 4 to 8 weeks, it improves soil structure and encourages earthworm activity in the root zone. Common misconception. A frequent error is the assumption that banana peel tea is a complete fertilizer. While it is high in potassium, it lacks significant nitrogen, which is required for leaf and stem growth. Relying exclusively on this liquid will lead to a plant that has plenty of fruit, but not enough foliage to protect that fruit from sun scald or to power continued photosynthesis. Use liquid extraction during the peak of the fruiting season, when the plant needs an immediate boost. For long-term soil health, use the dehydration method at the time of planting. Mix 1 cup of ground peel powder into the top 6 inches of soil per 10 square feet of garden space before setting your transplants. This ensures a steady supply of potassium and phosphorus as the plant matures. Liquid extraction is like a caffeine shot for the plant. It works fast but wears off. Trenching and powder application are like a balanced meal that sustains energy over a long workday. Use the fast-acting tea for immediate needs and the dry material for long-term stamina. Effective delivery requires more than just placement. It requires a healthy relationship with the microscopic life living within your garden beds. Point 3. Soil microbiology and the carbon-to-nitrogen ratio. The success of any organic amendment depends on the carbon-to-nitrogen ratio and the activity of soil microbes. Banana peels have a carbon-to-nitrogen ratio of approximately 11 to 1. In soil science, any material with a ratio below 20 to 1 is considered nitrogen positive, meaning it will release nitrogen as it decomposes rather than stealing it from the soil. This makes banana peels an ideal amendment because they do not cause nitrogen tie-up, a common problem where microbes consume all available nitrogen to break down high-carbon materials like wood chips or straw. When you incorporate peels into the soil, you trigger a surge in the population of actinomycetes and basidiomycetes fungi. These organisms specialize in breaking down the cellulose and lignin found in the peel's skin. As they work, they convert the organic molecules into inorganic forms, like potassium ions and phosphate ions. This biological conversion is temperature-dependent. In soil cooler than 55 degrees Fahrenheit, 13 degrees Celsius, microbial activity slows significantly, meaning the nutrients will remain locked in the organic matter until the weather warms. Common misconception. Gardeners often worry that burying peels will attract pests or cause root rot. While surface-applied peels can attract fungus gnats or rodents, buried peels do not present this risk if covered by at least 4 inches of soil. At that depth, the decomposition is handled by aerobic bacteria and fungi that do not produce the odors associated with surface decay or anaerobic rot. To maximize microbial efficiency, Always ensure the soil is moist but not saturated when adding peels. Microbes require a film of water to move and reproduce. If you are trenching peels, chop them into half-inch pieces first. This creates more entry points for the bacteria, accelerating the release of potassium by up to 40% compared to burying a whole peel. Imagine the microbes as a construction crew and the banana peel as the raw building materials. If the materials are delivered in one giant block, the crew can only work on the outside edges. If you chop the material up, you're giving the crew many small pieces they can work on simultaneously, finishing the building much faster. With the science established, let's look at how to apply these techniques to a specific garden scenario for maximum impact. To apply this knowledge effectively, follow this step-by-step guide for a standard summer garden bed containing 3 tomato plants and 2 pepper plants. 1. Preparation of the liquid supplement. Collect 5 to 8 organic banana peels. Place them in a 1-gallon glass container and fill with filtered water. Let this sit at room temperature for exactly 72 hours. After 3 days, strain the liquid. Dilute this concentrate at a ratio of 1 part tea to 5 parts fresh water. Apply 1 quart of this mixture to the base of each plant every 14 days once the first flowers appear. 2. The trenching method for established plants. Dig a narrow trench approximately 5 inches deep and 6 inches away from the main stem of your plant. This distance ensures you do not sever the primary taproot. Place 2 chopped banana peels into the trench and cover completely with soil. Firm the soil down to eliminate air pockets, which can cause root dehydration. Expect this to provide a nutrient surge roughly 3 weeks after burial. 3. Dry amendment for new plantings. If you are still in the planting phase, use the dehydration method. Slice peels into thin strips and dry them in an oven at the lowest setting, 150 degrees Fahrenheit, for 4 hours or until they snap when bent. Pulse them in a blender to create a coarse meal and add 2 tablespoons of this meal to the bottom of the planting hole, covering it with an inch of soil before placing the plant on top to prevent direct root burn from concentrated minerals. 4. Monitoring and adjustment. Observe the lower leaves of your plants. If you see yellowing at the edges, necrosis, this is a classic sign of potassium deficiency. Increase your liquid tea applications to once per week. If the plant is dark green and growing vigorously but has no fruit, hold back on any high nitrogen fertilizers and stick strictly to the banana peel supplements to encourage reproductive growth. While banana peels provide valuable supplemental minerals, they are not a substitute for a balanced soil management program. Organic amendments like these work best in soil that already contains adequate organic matter and a stable pH between 6.0 and 7.0. If your soil has a severe mineral deficiency confirmed by a professional soil test, localized amendments like peels may not be enough to correct the imbalance in a single season. Always use these methods as part of a broader, integrated gardening strategy. Banana peels contain up to 42% potassium, making them one of the highest potassium organic waste products available for the garden. The C to N ratio of 11:1 ensures that the decomposition process will not deplete the soil of nitrogen. Liquid extraction, soaking peels for 72 hours, provides the fastest delivery of ionic potassium for immediate plant uptake. Burying peels at a depth of 4 to 6 inches prevents pest attraction and facilitates aerobic decomposition by soil fungi. Drying and grinding peels creates a slow-release fertilizer that remains stable for many months. You now have a factual, science-based framework for converting household waste into a high-potassium soil amendment. By understanding the mineral content and microbial requirements of Musa peels, you can directly influence the health and yield of your summer vegetable garden. Implement these delivery methods today to ensure your fruiting crops have the resources they need for a successful harvest. This is the Herbatruth approach to practical, resilient gardening. What organic amendments have you tested in your own soil this season? If you found this technical breakdown useful, subscribe for more direct, fluff-free gardening education. For a deeper look at soil chemistry, watch our previous video on nitrogen-fixing cover crops. Detailed guides and mineral charts are available in the description below. Keep your soil healthy and your garden productive.